transmission purpose. Okay, so we have like the analog modulation, digital modulations, pulse modulations. So we'll be looking the different types of modulation techniques here. So when you have this modulation system, so we have like a source. So the source, whatever the information you have, that's will be encoder. So through the source encoder, then we'll be looking the channel encoder. Then we will be having the modulator. Okay, so this modulator, so all the informations will be converted, then it's transmitted through the channel, then we'll be looking for the demodulator. So from the demodulator, so then the decoder, channel decoder and source decoder, so we will be getting as the informations. Okay, so this is your informations you will be getting. So this is the entire system, how it's working. So some modulation, the general block diagram we can say. So we have here the why we are looking for this modulation techniques. So definitely we need to have the informations suitable for the transmission purpose. Okay, so when you have uh, uh, suitable for the transmission purpose, so we'll be looking for the different aspects. Okay, so what is the channel capacity, what is the data rate, we can, so how many bits per second, then what is the required bandwidth we have, then what is the noise. Okay, so this noise also is one of the important parameter we need to look when you are looking for the transmission purpose. So when you have the channel capacity, so which is going to give the what kind of what amount of data, so the maximum rate of so the data that can be transmitted for the through the particular communication path, so that will give you the channel capacity. Okay, so this the channel, based on the channel capacity, so we'll be transferring the informations. Okay, so how much it's this also it's we need to have the for the specific conditions and all. Similarly, the data rate, so how much data can be communicated, so data can be communicated with that. So impairments also will be happening, so like a noise, sometimes you will be having the limited data rate. Okay, so how much it can be achieved and everything. So say example, the data rate speed, the usually we will be having the internet connectivity, so we will be saying that 50 mbps, 100 mbps, but what is the data rate for that particular the second is very very important. Similarly, we have like a bandwidth, so this bandwidth is whatever the signal we are going to transmit. So it's considered by the transmitter. So that will be given as it in the range of hertz. So then the noise is very very important. So impairments on the communication. So definitely some the noise can. So we need to have the remove filter, some kind of filtering techniques to remove the noises and other things. So the error rate. So this error rate also will be calculated rate at which error occurs. Okay, so whether you are transmitted 1, so and received 0. Okay, if you are transmitting 0, you are receiving 1, that is nothing but the error. Okay, so our aim is to get here, if whatever the original information we are transmitting, so that information has to be received in the receiver hand. Okay, so if you are not receiving the exact information, then the error occurrences. Okay, so this is the digital modulation and the demodulation techniques. So we have like the data, so which is say example in the binary numbers, zeros and ones. Okay, so the data will be given to the modulation techniques. So then you'll be taking for the analog baseband signals, then you will be looking for the analog modulation. Once the signal is converted, so you'll during the analog modulation you will be adding the carry to the signals on the person. Then you will be adding the signal to ready for the transmissions. Okay, so then and from the transmitter end you will be transmitting the signals. Then you will be in the receiver end you will be receiving the signals. Then you will be looking for the demodulation techniques. Then you will be looking for the original information, the digital data in the radio. receiver end vehicles. So this process will take place in this. So when you are looking for the characteristics of the signals, so we can modify the amplitude, we can modify the frequency, we can modify the phase also. Okay, so this different phases can be different. Okay, so the the people might be aware of the process of the signal processing. So how the amplitude variations, the frequency variations, as well as the phase variations and all those things. So when you look for the modulation techniques, so you will be converting the signal. So you will be converting the information, so either the digital or analog informations. So to converting into the suitable waveforms. So why we are looking for the suitable waveform for the particular the transmission purpose. Okay, so whatever the facility is given to transmit your signal, so you need to convert it into suitable form. Okay, so for converting the suitable form, we'll be involving some parameters. Okay, so as a carrier wave, so that can be added with the original information that can be transmitted. Okay, so we know that we can modulate the amplitude, frequency, as well as phase. So we'll be modifying the information. So changing the parameters like a amplitude shift keying, ASK, PSK, FSK. So shift keying. So you just you are altering the information. So okay, so the parameter can be changed. So the ASK, PSK, and FSK. So we'll see in the next slide how this can be taken over. Okay, so when you look for the modulation techniques, so why we are going for the analog modulation techniques methods and all those things, we have the better performance and as well as cost effective than the analog modulation. That is the reason we are going for the digital modulation techniques. So when you look for this, lot of applications we have. Okay, so with the digital modulation techniques. So when you look for digital modulation techniques, so we need to look a few areas we need to consider. So the performance factors, so to improvise. So the low bit error rate, so we are at a low signal noise ratios, occupying the minimum amount of bandwidth, because the bandwidth is requirement is huge. If you are using your occupancy in the minimum bandwidth, minimum amount of bandwidth, then it's easy for to transmit the informations and all those things. Okay, so to implement in the advanced criteria and all those things, so we'll be looking for the cheapest one as well as the easy to implement, so in the mobile unit. So this is also one of the efficient one we can say as a when you look for. So these are the performance factors we need to consider when you're looking for the digital modulation technique. So this is the examples I'm showing here. So the digital modulation techniques. So how the amplitude shifting is happening, the frequency shift key, as well as the phase shift key. So you can look here. So the amplitude variations. So we can say as that this is the minimum level, the maximum level of the amplitude. Okay, so when you have here, okay, so say example, the range is going up to 1 here. Okay, so now if this amplitude now here it's looking at 0 level with respect to the time. Okay, so the data we have like a amplitude 1 1 0 1 like that, it goes like that. Okay, so this is the amplitude shift key. Okay, so whenever the changes are occurring with the amplitude, so it can be repressed also. Okay, so this requires a low bandwidth requirements. Then when you look for the frequency shift keying, so we have the frequency range. You can see that. So the range is varying here. So with the each symbols. Okay, so this needed larger bandwidth. Okay, so when you have the phase shift keying PSK, so changes with the phases. So you can see here when you are altering with that. Okay, say the so following it's a kind of on off condition. So like as a sinusoidal wave will go on off like that. Okay, so here when you look here, the changes are occurring in the phase shift is happening. Okay, so this is a this is one of the complex method. It's a again it's a kind of the robust we can say with the in reference analysis. Okay, so this is an example how the digital modulation techniques is happening. So this is a amplitude shift keying. You can look very you can look this information. So how this information on off keying is happening. Okay, so there are two levels. So one is the one and zeros and ones. So the zeros represents in the low level, one represents in the high level. Okay, so this is an example it's shown here. So the sequence is given here. You can look here. It's like a 0 0 1 0. Okay, so 1 1 0 0 1 0. Okay, so this is the level of the sequence. Okay, so this is the your data now. So that's 0 0 1 0 1 1 0 0 1 0 is your data. So this might be changing with the corresponding levels will be reflected in the zeros and ones. So the on off keying, this is the on off keying. But similarly, we have like a and the frequency shift keying. So you can look and you can have the information. So already I told you this this line, you can see that 0 0 1 0 1 1 0 0 1 0. Okay, so how this frequency is altering here, you can see that how the frequency range is altered here with that. Okay, so the similarly we have like a the PSK. So the phase will be shifting. So we know the data is the same. Okay, 0 0, now it's 1 0, so it has to transit to the 1. Okay, so 1 0 1 1 0 0 1 0. Okay, so the transition will takes place end of the entire data. Okay, so when it's ending with the 0, again its transition will takes place for the 1. Okay, so immediately it will be. So this is the PSK. Okay, so the when you're looking for the shift keying, so you have the binary phase shift keying. So this is also one of the use of alternative sign with phase to encode all the bits. So this can be used for the separated by the 180 degrees. It's also one of the very simplest method to implement. So whenever the inefficient use of bandwidth and all those things. So it's one of the very robust thing. So it can be used. So this BPSK is used for the satellite communications and all those. Okay, for your information. So when you look for the binary phase shift keying examples, you can see that the data we have 1 1 0 1 0 1. Okay, so when you are adding with the carrier, okay, so the carrier signal is added here. So you can check here, the carrier signal is added. So here we have like the carrier signal. Okay, so once if added, so we have like a carrier specified. Okay, so this is the waveform we have. So the shifting is happening, you can see here. So the shifting is happening. So 1 1 0 1 0 1. Okay, so the shifting is, this is the binary phase shift. So continuing with that, some different modulation techniques. So for your information, then we need to know about the different types of antennas, whatever we are using in for the transmission purpose. Okay, so we have like the wire antennas. In the wire antennas, we have the different classifications: dipole, monopoles, and above ground level. Okay, so those are all the antennas we have. Then we have like a patch antennas, then the printed circuit board antennas. We have the different slots, apertures, we have dishes, reflector antennas, we have then arrays of antennas we have. So one thing you need to understand here, whenever you are looking for the antenna, so even the mobile phone, whatever we are using, we have antenna. But the earlier, the initial stage of mobile phones, we have the longer antenna. It will peep out of the mobile phone, so it will be Now the antenna size is reduced, so it is invisible. It's inside somewhere in the mobile, but the range, coverage of the range is increased now. Okay, so that you need to understand. So the lot of different types of antennas we have, starting from the dishes, what we are using in the home. So the DTH services, the direct to home. So that direct to home, everybody is using now. Earlier we used to have the cable connections from the cable operator and all. Now we have the dishes. Each and every home we have the dishes. So directly it's connected. So that all the transmission, the receiving will takes place. So we are watching the TV. So you need to understand. So that's the um, different dishes are used. So, say example in the internet connectivity, we are using the different, and that's what we are going to see here. So the different antennas. So when you look for this is the one I want to show you, the monopole antenna. This is the one of the loop antenna, disc cone antenna, different types of antennas we have. So for your information only, what are the antennas we are using for the transmission purpose. Then we have the reflected dish antenna. So we were using. Then the GPS antennas we were using. So the dish antenna everywhere in every home we are using right now. Say example in movie theaters, if you visit, there also we will be having the antenna to receive all the signals. Because this is why it's very important means when you are practicing the telemedicine, we need to connect to the rural area. So if you know about what are the different types of antennas we have, then the establishing the connectivity will be easier. Okay, so you would have seen this different types of helical antennas, on antennas. So this all the dish antennas, with that. Okay, so for your references. Okay, uh, this you would have seen in the the older, if you want to see the Doordarshan and all those things. So we have used this kind of antennas. Okay, so nowadays nobody is using this kind of antennas. Okay, so we have like a kind of transmitting towers also. So it's located everywhere. So that the signal will be received. So this is a different application. So this UHF and the VHF FM antennas we use to see the regional languages and as well as the national languages, television channels and all those things in the earlier stages before this cable operator and dish antennas and all those things. So just to have the reference. So the wireless communications, we have the 1 by 4 wave helical, then 1 by 4 wave, two in one we have wave, wipe we have the cardless phones we have in the home. We have walkie-talkie. The personals they will be using, right. So the communications establishing within the range. Okay, so within the range. So this can be connected in the wireless communications. So the security persons will be using. The police person will be using. So this all different types of antennas we have. The grid dishes you would have seen somewhere in the to get the internet connectivity and others. So this is also different types of antennas we have. Why this we want to establish with the antennas and other things? We want to create the point to multi-point links because we have like a we have the one point is say example we have like this is reference centers. So this reference centers building will be connected with the different nodal centers. Okay, so all the information has to be taken with them. So when you want to establish the connectivity between the different buildings or the different locations, so we need this kind of links to be enabled. Okay, so this is a point to multi-point links we have. So through this, the communication will be established. Then we will be getting all the information, sharing the information with that can be taken here. Okay, so when you look for this, so for the telemedicine purpose, so we'll be sharing the information on time, so that communications can be established. So this we can say as an example is here different villages which is connected through the district headquarter. Okay, so within the range we can say. Okay, or we can say as in the metropolitan city. So in the radius of the lesser kilometers are in the organizations. We have the different buildings. We will be connecting with the point to multi-point links. When you have this point-to-point links, so they'll be using the directional antennas. So this directional antennas will be connected with the two different locations to establish the connections. Okay, so this can be used in the organizations as well as this can be used for the connecting with the say example the nodal center to the reference centers. Okay, so when you are establishing this connectivity and all those things, we are ensuring that the telemedicine practice will be in the benefit. Okay, so because the remote locations also can be connected. Okay, so when you are connecting with the remote locations, so everybody will be getting eligible to get the kind of treatment in time. Okay, so that is what the establishing the connectivity through this antenna. So the different antennas